I'm sure you've all heard the expression that smart contracts are neither smart nor contracts. So what we do at Clause and within the Accord project is to try to address that. Clause is a legal technology startup. We exist to help law firms and companies using contracts to automate legal agreements. So what we're going to do is take you through a very short introduction to some concepts, what the Accord project is about, and then we hope that we'll spend most of the time this afternoon with you, with your fingers on the keyboard, discussing the ideas that we have in the lab, and we won't be here presenting and pitching to you for very long. Okay. So we'll spend probably not 20 minutes actually just doing that introduction now, and then we have the rest of the afternoon for the lab. There is a break scheduled in the middle, but feel free to leave and come as you wish, and nobody else will be coming in here during that break. So first of all, I'll spend a little time introducing the Accord project. So I said that Dan and I work for Clause. That is a commercial entity. But Clause is the founding member of an organisation called the Accord project, and that exists to set and define the specification and standards for smart legal agreements. That organisation has over 200 members, including more than 50 of the world's largest law firms, technology companies. You can see some examples of our members on the bottom, as well as standard bodies like IEEE, the International Organization for Standards. This is the American Contracting Association in the middle as well. So that is a not-for-profit organisation. That organisation defines specification in the open, it defines open source code, and it's tools from the Accord project that we'll be using in the lab today to build smart legal agreements. Those tools that have been built by the Accord project are platform neutral. We support a number of different platforms, both ledger and non-ledger based. So we believe that the platform will be decided by the use case. Some will be best suited to Fabric, some will be best suited to Corda, some won't need a DLT at all. May get shot for saying that here. But we believe in some cases the relationships between the parties in the agreement mean that it's quite appropriate for a single organisation to run that contract, that legal agreement, in their own data center or in the cloud, for example. So you'll see us taking advantage of some of that behavior in the tools that we're using. There are a number of components to those tools, and we'll be using some of these today. You'll see Cicero, which is the templating system. This is really the magic that joins together legal text with logic. So we don't believe, certainly in the short and medium term, that there's a reliable and an ambiguous way of generating computable code from unstructured natural language. So we deliberately make a distinction between the two, but we bind them together in a very tight way through a data model that we'll talk about. So Cicero is the templating system that lets us do that. Text with parameters and placeholders, so you can have reusable clauses, reusable documents, but also logic that corresponds to the text in those contracts. We also have defined, again in the open, a domain-specific language called Ergo. So Ergo is a language that understands as primitives the concepts of a contract and clauses. It understands the state of a contract. It understands that data can be sent to it. And we believe that it's accessible to less technical people. There are some more technical properties that it has that we think also make it suitable for running on a distributed ledger platform. So for those of you that are interested, Ergo is non-Turing complete, deliberately so. It's built in a way that means that we can formally verify it using proper academic formal verification tools. It's type safe, but it also, because it's platform independent, we can compile it and produce code that will run on whatever platform we want. So today we're going to be compiling Ergo to JavaScript. That will be done behind the scenes. You won't need to worry about that. And that means that we can run on a node runtime in a Hyperledger Fabric instance. But we also support currently Java, as a back-end target, and we have others in the pipeline too. The other things that we'll see are some libraries. So the data models, the logic that we build, the templates, a lot of these things are reusable and valuable to others. So we'll be using some resources, template libraries, and a model repository to help accelerate some of the work that you'll be doing today. And finally, we provide some end-user tooling for developers of these templates, particularly something called Template Studio, which is an in-browser editor for modeling the natural language and the grammar of these templates, the logic, and the data model too. Okay, all still with me? Make sense so far? Good. So this is what we mean when we say a template. What is a smart legal contract template? The way that we bind logic on the left-hand side and natural language on the bottom right-hand side is through a data model. We define that a person has specific attributes, and when you refer to that person in text, we can parse that text automatically and extract the data. So there's a clever bit there. The logic that performs calculation on those attributes uses the same model. So we have that binding between the text and the natural language through the data model. For those of you that are interested, the modeling language that we use is called Concerto, which has recently come from the Hyperledger Composer project. So we had a session yesterday where we talked about the work that we've done to extract that component and make it an independent module that can be used on a number of different platforms, and that now has the name Concerto. So that gives us another level of platform independence and some other benefits like automatic form generation, generation of UML diagrams, and so on from those data model definitions. And we group those three things together into something called a template. So let's have a look at some examples of each of these. This is a really simple example. We'll be doing something a little bit more complex in the lab of contract text. So what we do is we take the clause from the lawyer and we identify the variable components of that. What are the parameters to that contract? So we can see we've got some parties, Betty Buyer and Steve Seller. We have some values, 10.5, 2 days, 55%, and so on. And ultimately, when I write a contract, I should be able to change the parties, change the values. The lawyer should be able to do that. But we can still parse that text and extract those attributes so that we can use them in our logic and or do clever things with them. Yes?
You do this manually, or you do some deep learning with virtual work?
No, we can generate a parser automatically from the templates to do that. So there's, it's a smart parser, so it will recognize strings and recognize numbers, for example, and the structure of complex types. So if you see 2 days is a complex type for a duration, that could say 1 month, 12 years, for example, and the parser will be able to handle that. But it's not an AI system that's doing that. It's not NLP. So we've identified those parameters. The next thing that we do with this this notation is build what we call a grammar. So we punch holes. We take all of those variable elements out and we make this reusable. And it's from this that we generate that parser that I mentioned. Again, you don't need to worry about how we do that, but you'll be creating and modifying one of these in the lab so that you can make your legal documents reusable. So for each of those parameters, we produce a data model. So here's a class diagram for the data model that corresponds to those parameters. We have some parties for the contract. We have the duration, some percentages for the values. So duration is 15 days, like we said. And there can be some fairly complex relationships between these models. So duration is defined elsewhere. That's a built-in type, if you like. And we know that a duration has an amount and a unit. So is it seconds, minute, hours, or so on. And one of those libraries I referred to, the model library, provides a whole suite of reusable libraries that you can use in your contracts. So we have the text, we have the data model. We then need to start thinking about the logic and how we integrate logic with that. So we've done these things. We've started on the top right with contract text. We've converted that to a contract template. because of that model, we can generate an instance of the contract. We can pull out the data, and we serialize that into JSON. So that's one option for, that's the serialization format that we've chosen. So that's what that looks like. A complex type is a nested object here. So that's sometimes referred to as the deal data. So for the lawyers amongst you, that tends to be the terminology that's used. The contract, because it's no longer just a PDF or a Word document, it's now a living thing. So we need to think about the life cycle of that contract. How does it respond to data from the outside world? How does it remember what it's seen before? And use that information in the logic to decide what to do next. So we've instantiated the contract from a template, provided values for the placeholders. We have a contract instance, and we can send data to it. We call those requests, and we get responses back in based on our request. Those requests could cause a change in the state. So in this example, late delivery and penalty, maybe there are multiple packages, or we remember whether the package has already been delivered, for example. And if we receive a request once the package has already been delivered, we record that in the state so that we know not to do something again the next time. And the things that we might do are to emit an obligation, for example. So in many clauses, there'll be an obligation for a party to do something. Maybe in certain circumstances, somebody needs to make a payment. So the contract can emit an obligation. You can think about that as an event in Fabric terms, if you like. And then we can surround this contract with a system which can automate that obligation. We can perform a payment automatically, for example. If the contract decides that somebody has to pay somebody else, why not make the payment automatically? And again, we are not mandating what that payment channel is. That payment could be a traditional payment gateway online using the MasterCard gateway or Stripe, for example. It could be that, heaven forbid, we want to do that in a digital currency scenario. It could be that actually, for some people, automating payments is a bit too risky, that they want some level of sense checking. So we just give somebody an alert, send them an email, or we want to add a line item to an invoice which goes through a normal accounting cycle. So again, there's those design decisions to be made outside the system as to how we respond to the output, the events and obligations emitted by the contract. So you'll see these concepts as we go through the lab. Yes?
I was just asking regarding payments, so your platform also supports the making of this payment, or do I need to implement it myself?
So I'll make the distinction that everything that you'll use in the lab today is provided by the core project in open source. At that level, we don't provide any infrastructure for wiring up. And if you want to adopt this stack, it would be your responsibility to do that wiring. As Clause, what we do is we provide a SaaS platform which helps you with those connecting those Sorry, I'll stand over here so you can hear me. Okay, and of course each of those components is also represented by this structured data model so that we can verify that the data being sent in has all the right fields and it's of the right structure. Okay. The final part that I said I would introduce you to is the execution logic, and here's a simple example of some of that Ergo code, the domain-specific language. So you can see here that we're doing some variable assignments. A request is the input data that is coming in that I referred to. So the request tells me when the... not sure what happened there. Tells me when the package was delivered, in this case, in the late delivery scenario example. And I can write an enforce statement that says that the delivery has to be before the agreed date. You can think of that like an assert statement. We might also do things like conditional expressions. If the penalty is above a cap, then it determines what the value of the obligation is that's emitted. Yes?
You said it's a functional language. From which language have you looked at for building it? Like inspired by Haskell? Or?
Yes, so it's taken inspiration from lots of places. So we did a very thorough evaluation of lots of smart contract languages before deciding to build a new one. There's inspiration from some from Haskell, some from Swift. There are some keywords that you might recognize from Solidity, perhaps. There are some keywords that you'd recognize from JavaScript. What else am I? Anything obvious I'm forgetting?
It's implemented using Coq, so if you're a language geek, then there's some inspiration from Coq as well. So it's an interesting language that mixes some OO concepts, in that contracts are kind of like classes and clauses are kind of like methods, but then it's also a functional side effect-free language.
So in most of the lab today, you won't be expected to write any new Ergo in the basic set of instructions, but then there are some advanced instructions. So for some of you that may rattle through the first set of instructions very quickly, there are some extension exercises where we encourage you to add additional use cases to the template that you start from. So we're here to help and guide you through that if you have questions on the language. Before I give you the instructions to start the lab, here are a few resources. I'll put these back up again afterwards that will be helpful as we go through. The left-hand side is the core project documentation website. So that gives you detailed documentation on Cicero, Ergo, and those resources for templates and models that I mentioned. And on the right-hand side, if you go to coreproject.org and click Join the AP Slack, we have a Slack channel called Tech Hyperledger, which we use for general Hyperledger discussion in the Accord project. So we thought it would be great if you have questions, if there are common things that come up, we can share those with you, code snippets, that kind of stuff. So we'd strongly encourage you all to join that.
At the beginning you said you are somehow ledger agnostic.
Yes.
To which ledgers are you able to connect, or what is your preferred?
Yeah, so currently we have support for Fabric. That's the one we'll be using in the lab today. We have experimental support for Corda, and we have the team working on others too. So we're interested in Tezos and running on the EVM in particular. And of course we can run off-chain too. So we can run in a Node.js runtime or in the browser. So you'll be doing some testing in the browser, transparent to whichever platform you want to do to begin with today too. Okay, so the lab exercise. The lab is set up to try and accommodate different levels of technical ability. So there are 3 different options for you. We have some pre-built images in the cloud, so we thought that asking 30 or 40 of you to all download a 6 or 10 gig image before you begin was probably not a great idea. So we have some images that you can log into via a remote desktop connection. So that's the most straightforward way to get started. And if you think that's the best option for you, come and see us and we'll give you a post-it note with an IP address and some credentials so you can just log in. You should be able to log in from any remote desktop client on your machine. Option number 2 is the image that we use behind the remote desktop machines is available in the Frankfurt AWS data center. So if you have an AWS account, you can provision your own image and you can keep it after the end of the lab. So there's instructions in the lab on how to find that image in the EC2 community marketplace. Or finally, if you're feeling really adventurous, we've listed all of the prerequisites and requirements that you need to install. Basically, you need Node, Git, Docker and Docker Compose installed on your machine with appropriate versions. So you can have a go at doing that yourself too, subject to the Wi-Fi holding up.
But if you've used Fabric 1.3 already on your local laptops, there shouldn't be very
You've probably got it all there. Yeah. The exercise then, sorry.
Will it work on Windows, or you essentially check what you require?
Yes, so no. So we haven't got instructions natively for Windows, so we recommend you use a hosted image or a virtual machine or something.
Thanks.
We're going to use a perishable goods scenario, so a perishable goods contract. So that contract already exists in a non-automated way today. When I ship something that needs to be kept within a certain temperature range or within a certain humidity, avocados, sugar are the two things that we've, we've had organisations that have worked with us shipping those kinds of produce. There's a contract that says that if the data logger in the container shows that the reading goes outside of the range, the shipper has to pay a penalty. So the total amount payable is not determined until the shipment is received. Now, if we automate that process, we can listen to events from that container in real time, we can send up notifications as we go along, and we can determine the actual obligation on receipt of delivery. So we have natural language contract, we have logic which processes those IoT sensor events, and we can store those events on chain, we can run the logic on Fabric, that's what we're going to do today, and perform that obligation calculation automatically. In the lab, you'll go through building the templates, using the template studio, and then deployment to your own local Fabric instance. That's sort of the first easy step, easy couple of steps, and then some extensions to the activity, for example, to make the contract more stateful. How do we record what data we've had before rather than sending it all in one go? How do we deploy this, and how does it work across a network rather than in a single node, for example? So there's about 5 or 6 extension exercises that you can choose as you wish towards the end. This is the final slide. Lab instructions are at that URL at the top. So lab instructions for all 3 of those variants, whether you use the remote desktop image, provision your own, or deploy it to your own machine. To save the Wi-Fi, we recommend not downloading Ubuntu and everything locally. We might do an unintentional denial of service on all the other labs going on at the same time. And we have about 20 or so pre-built images that Dan's got here that we can give out to you. So that's why we collect your email addresses. The images are only going to be available for the lab and shortly afterwards, so we'll deprovision them. So it's just so that we know who is using those images, so we can bring them down. Right, I think that's all I've got to say. So are there any questions before I set you going? Yes?
So when is this live? I mean, are you live now? Clause live?
Yeah, Clause is in public beta. Yeah, so you can go to clause.io and sign up for Clause today. It's open for anybody to sign up. I'll be completely open. We are not using any Clause proprietary technology. Everything here is open source, Apache 2 licensed. Of course, we'd love you to go and also have a look at Clause and talk to us about that as well, but there's no mandate for you to use Clause technology in the lab. Yes?
Do you have a visual editor to generate your encoding, for instance?
No, we don't. But if you have some ideas about that, we'd love to talk to you. Great. Right.
So if you would like to use one of the pre-built images, please just come and see me. I'll give you an IP address and we'll associate your email address with the IP address. This is a pretty old-fashioned, not digital process.
The other thing that I'll say, and you're free to do this how you wish, I often find with these kind of labs it's really helpful to do them with somebody. Because you follow the instructions and you get to the end, and often you don't fully appreciate what it is that you've done. If you're working in pairs, there's a natural tendency to question and try and figure out why you're doing it this way, what's the benefit of doing it. And maybe if there are people who are less confident, want somebody to help them, and we can facilitate finding you a partner to work with. It's entirely up to you. You can do it all your own, independently, or work with somebody else as you wish.
I'm open for business. Yes. Basically, just find yourself. Okay, so